Today, we're going to dive into something pretty radical. It's a whole new way to think about AI. We're going to explore what it would take to move away from a world of just statistical guessing and towards a new kind of machine intelligence, one that's built from the ground up on verifiable cryptographic truth. So let's see how this works. Imagine for a second that you're about to take the biggest exam of your entire life. You prepared by memorizing every single question and answer from the last decade of tests. You're just flying through it and then, boom, you get hit with a question you have never seen before, a total curveball. So what do? You try to average out the answers you remember, you write down something that sounds about right, and it's completely wrong. Why? Because you had perfect memory, but you didn't actually understand the material. Well, that is the exact problem with today's AI. The source material gives us a couple of really powerful ways to think about large language models. First, think of them as these incredibly sophisticated photocopiers. They can reproduce meaning with amazing fluency, but they have zero comprehension of what they're actually copying. Or here's another one. Think of an LLM as a perfect mirror. A mirror reflects light beautifully, right? But it doesn't create any light of its own. So the important question is never, how good is the mirror? It's, where is the light actually coming from?
Okay, so let's get right to the heart of this illusion. Current LLMs are what the source calls dynamic semiotic machines. And yeah, that sounds fancy, but all it really means is that they are world-class experts at shuffling words and sentences around. They can organize and recombine language without any real intention or grasp of the concepts behind those words.
Now, what's so fascinating here is just how simple the basic mechanic is. When you type a prompt into an LLM, it isn't thinking, not at all. It's running a purely statistical calculation to predict the most likely next word based on the trillions of sentences it's already seen online. It's just mimicking the patterns of human intelligence. The actual understanding, that aha moment, that happens entirely inside your head, not inside the machine. And here's the real kicker. This isn't some bug that we can just patch in the next software update. The flaws that we see in LLMs, the hallucinations, the nonsense, that's not a software issue. It's actually hard-coded by the unchangeable laws of mathematics and geometry. So here's the crucial point. An LLM works by what's called interpolation. Just think of it like a student who can only create answers by averaging what all of its teachers, the training data, have told it. So if the very best data point it has is, say, an 80 out of 100, the student's average answer can never be better than 80. It's mathematically impossible for it to generate a truly new insight that's better than the best of its inputs. It's a hard ceiling.
This is such a brilliant way to illustrate the alignment problem. See, the knowledge inside an LLM is all tangled up like a curved sphere. And when we try to make it safe or aligned, it's like we're trying to flatten that sphere onto a table. It's just geometrically impossible to do that without tearing the orange peel somewhere. And in AI, those tears show up as weird refusals, strange answers, and hallucinations. You try to fix one problem over here, and you just end up breaking something over there.
And these mathematical limits, they lead to three really catastrophic types of failure in the real world. First, there's hallucination, where the model just makes up plausible-sounding nonsense. Then there's mistaking correlation for causation, where it sees a pattern and assumes one thing causes another. And maybe the most dangerous of all is silent failure. That's when it gives you a completely wrong answer with the exact same confident tone as a right one. So this brings us to a huge turning point. If the very mathematical foundation of this whole approach is flawed, well then just tweaking it isn't going to be enough. We have to start asking a much bigger question. What if we just replace the entire architecture? The proposed solution is to just completely abandon the chaotic, tangled mess of statistical models, what's technically called an implicit vector embedding, and replace it with a structured, clean grid of meaning, an explicit semantic topology. It's a huge shift from that curved, unpredictable space to a flat, verifiable one. We'd stop asking what words sound right together and start asking, what claim can I actually prove? All right, so let's take a look at how this new foundation could build a totally different kind of AI. This new model, which is called the Semiotic Web, represents a fundamental move away from just statistical mimicry and towards real cryptographic comprehension. So the most basic building block of this new system is something called a token. Now, unlike the anonymous, jumbled vectors inside an LLM, a token is a named, verified, and completely traceable unit of meaning. It's designed for clarity and for being able to check its work right from the very start. And every single token has 3 layers. First up is its identity.
which is like a stable, permanent address for a concept. Second is its context, which is a verified statement about how that concept is grounded in the real world. And third, you have the provenance chain, a cryptographically linked trail of evidence that lets you see exactly where every piece of information came from.
Now, this structure, it unlocks one of the most powerful features you could ever imagine for an AI, the ability to know what it doesn't know. This is a total game changer, and it's called structurally bounded refusal. When you put the two systems side by side on some critical measures for intelligence, you see why this is so huge. LLMs completely fail at having a global workspace, basically a way for all parts of the system to be aware of each other, and they have zero ability for self-monitoring. But the semiotic web, by its very design, it can do both. It can actually inspect its own state of knowledge. And this is how it works. When the system gets a question about something for which it has no verified, provable link, the computation just stops. It physically hits a wall. It is incapable of guessing or averaging nearby answers. It simply outputs evidence underscore required. And that's not some confidence score. It's a structural, mathematical limit. Hallucination is impossible by design. Okay, let's make this super real for a second. Imagine a doctor rushing around in a busy hospital. They need to check for a potentially deadly drug interaction. I mean, the stakes just don't get any higher than this. So on the left, you've got this massive, power-hungry LLM server churning out a probabilistic guess, something like 87% confidence. And a tired doctor who's used to false alerts might just ignore it. But on the right, you've got a tiny 1-watt semiotic web node that does an exact verifiable lookup. It returns the confirmed interaction along with a full cryptographic paper trail. It's the difference between a guess and a guarantee. You know, this whole new approach really forces us to come up with a completely new definition of machine intelligence itself. True AI isn't about how much knowledge a system can hoard, but how efficiently verifiable information can flow through it to solve a real problem. This slide really brings it all home. The past is statistical AI. It's all about pattern matching and creating this illusion of comprehension. The future, which the source calls agapistic influence, is built on a completely different foundation: topological verification, cryptographic proof, and the reality of genuine, provable understanding. And that really leaves us with one final, and I think really provocative thought. To build systems we can actually rely on, it isn't enough for an AI to just know an answer. It has to be structurally capable of telling the difference between a verified truth and a plausible-sounding story. So if that kind of AI is possible, why on earth would we ever settle for anything less?